Imagine falling from space, an endless expanse of darkness, stars twinkling in the distance. What would it feel like to fall from space? The truth is, it's not quite like falling on Earth. In the vacuum of space, there's no air to slow you down. You'd accelerate continuously, reaching speeds that would make a Formula One car look like a snail in comparison. The stronger the gravity, the faster you fall. But here's the kicker. Space is big, really big. So even at these mind-boggling speeds, the journey would be far from a quick one. Now let's add a twist to our tale. Instead of falling towards Earth, you find yourself plummeting towards Jupiter, the behemoth of our solar system. The distance between Earth and Jupiter is vast, to say the least. At their closest approach, these two planets are approximately 365 million miles apart. That's about 4,000 trips around Earth's equator. The journey to Jupiter, then, is a marathon, not a sprint unfolding over weeks, months, perhaps even years. It's a voyage through the void, a solitary descent into the depths of the solar system. Talking about speed. If we were to travel at the speed of light, which is approximately 186,000 miles per second, this journey would take about 43 minutes. But hold on, that's the speed of light, and we humans haven't quite cracked that nut yet. So let's consider a speed we have achieved. The fastest spacecraft ever launched by humans, the Parker Solar Probe, travels at approximately 430,000 miles per hour. As we travel further from the Sun, the temperature drops drastically. Near Jupiter, the average temperature is minus 234 degrees Fahrenheit. That's colder than anything experienced on Earth. The journey also comes with its own set of physiological challenges. Prolonged exposure to microgravity can cause muscle atrophy and bone density loss, not to mention the intense radiation from Jupiter's magnetosphere, which is far stronger than anything we experience on Earth. Without a special suit, this radiation would kill you 300,000 kilometers away from Jupiter, the same distance from Earth to the Moon. But let's say you've overcome all these hurdles because you have an ably protective suit on. You've traveled the vast distance, endured the cold, the microgravity, the radiation. So you've made the long journey and are now on a collision course with Jupiter. What happens next? First, you will definitely first fall through the thin and almost invisible rings. Here, you would clearly view the largest storm, the Great Red Spot, from afar. As you approach, you can't help but be captivated by the grandeur of its colossal swirling storms and the beauty of its banded cloud tops. You then fall through the white ammonia clouds. Gravity here is a formidable force, more than 2.5 times that of Earth's, so you would fall much faster than you would on Earth. You feel it pulling you in, pressing you down with an intensity that is both exhilarating and terrifying. This is the might of Jupiter's gravity. Remember, Jupiter's atmosphere, composed mostly of hydrogen and helium, holds no breathable air. As you descend further, the environment gets much darker as you fall through the sulfide and hydrogen sulfide clouds, which make the clouds appear brown. Deeper into the planet, the sun's light is unable to reach that depth, and it becomes completely dark. Pressure, too, builds up around you. It's a crushing force, unimaginable on Earth, that would flatten even the most robust spaceship like an aluminum can. But as you descend deeper, you realize something strange. There's no ground to hit, no solid surface to meet your fall. Jupiter is a gas giant made up mostly of hydrogen and helium, much like the Sun. Amidst its dense clouds, you'd find no land, nothing solid to break your fall. You just keep sinking, falling deeper and deeper into an endless sea of gas and storms. The vast banded clouds that once were a distant spectacle are now all around you, their brilliant hues a testament to the complex chemistry at play. You're in the thick of it, surrounded by an atmosphere that's a swirling, turbulent soup of gases. You've now plunged into the swirling maelstrom of Jupiter's atmosphere. 3,000 kilometers into Jupiter, you have reached the end of the atmosphere. As you descend deeper into the mantle region, the pressure is so immense that hydrogen is liquefied and it appears glowing white hot. This mantle is a large sea of liquid hydrogen, and it makes up majority of the planet. To reach the core, you would sink deeper into the liquid hydrogen for months. The core temperature, however, is estimated to be higher than the sun's temperature, and it's about 24,000 degrees Celsius hot. And finally, here comes the end of our journey at Jupiter's core.